Here R is equal to 336 kN, H is equal to 360 kN. This is the uniform distributed load. This is 24 kN per meter. This is 48 kN. This is 6 meter. This is 9 meter. This is 9 meter. RB is equal to 144 kN. Bending moment is 350 kN per meter. Approximately equals to 350 kN per meter. QX is equal to 6.5 or approximately equals to 6.5. NS is equal to 379 or approximately equals to 379. Then is the rolling loads. ILD is equals to influence line diagram. A curve or graph that represents the function of a line in terms of support reaction, shear force, bending moment at various positions on the structure is called the influence line diagram. For example, is the here influence line diagram for reaction at support beam. Case 1 influence line diagram for support reaction at B. This is A. This is 1 minus x by L. This is length. This is RB is equal to x by L. X is equal to 0. RB is equal to 0. X is equal to L by 2. RB is equal to 0.5. X is equal to L. RB is equal to 1. Their influence line diagram can be like that: 0, 0, 1, 0.5. Here is the case 2. It is X. This is L. This is 1 kN. This is x by L is equal to RB. This is RA is equal to 1 minus x by R is equal to x is equal to 0. R is equal to 1. X is equal to L by 2. R is equal to 0.5. X is equal to L. RA is equal to 0, 1, 0.5, 0. Draw ILD for shear force at section D. Then RA is equal to 1 minus x by L. This is Z. This is R is equal to 1 minus x by L. This is X. This is 1 kN. This is D. This is B. This is x by L. This is Z. This is L minus Z. This is L. Loaded in portion AD. Shear force D is equal to minus x by L. X is 0. Shear force D is equal to 0. X is equal to D. Shear force D is equal to minus Z by L. Loaded in portion DB. Shear force D is equal to L minus x by L. X is equal to Z. Shear force D is equal to L minus Z by L. X is equal to L. Shear force D is equal to 0. For example, here it is Z by L. This is L minus Z by L. This can be the plotting of influence line. This is positive. This is negative. Influence line diagram for bending moment at section D. This is 1 kN. This is RA. This is X. This is Z. This is L minus Z. This is RB is equal to x by L. This is R is equal to L minus x by L. First load is on section AD. Load is loaded in portion AD. MD is equal to x by L into L minus Z. If x is equal to 0, MD is equal to 0. If x is equal to Z, then MD is equal to Z into L, Z by L over into L minus Z. Load in portion DB. MD is equal to RA into Z is equal to L minus x by L into Z. X is equal to Z. MD is equal to L minus Z over L into Z. X is equal to L. MD is equal to 0. Then here it can be the influence line diagram. This can be the Z into L minus Z by L. Observations or note: maximum negative shear force occurs when the load is just to the left of the section. Similarly, maximum positive shear force when the load is just right of the section. Maximum bending moment at A section will occur when the load is on the section itself. Absolute maximum bending moment, it will be anywhere in the section. The absolute negative shear force occurs when the loading is at extreme end. This is maximum positive. This is maximum negative. The absolute maximum shear force occurs when the load is at extreme end. Influence line diagram ILD shear section SA-1. The maximum positive shear force will develop when the tail of the load reaches the section. Absolute bending moment. For example, this is the case. This length in the somewhere in the region is the UDL. This is L minus D by 2. This is D. This is L minus D by 2. Then here is the maximum absolute bending moment. Bending moment will be maximum when the ordinate just below the head and tail of the loading is equal. This is y1. This is y2. y1 is equal to y2. Then x by d is equal to z by l. A simply supported beam of a 15 meter span and 40 kN per meter UDL having a 5 meter span moving from left to right. Draw ILD at 6 meter from the left side support. Also calculate maximum shear force and bending moment at the 6 meter from left side support. 6 meter from left side support. ADB. AD can be the 6 meter. This is the 50 meter. This is A is equal to 5 meter. This is 40 kN per meter. This is 50 minus 6 by 5 is equal to 0.6. Then here is Z by L is equal to 60 by 5 is equal to 0.4. At the rate of between left support negative shear force half 0.4 plus 0. Positive shear force at Z is equal to 6 meter is equal to 86.67 kilonewton. This is D. This can be the UDL. X is 2 meter, X is 3 meter, X is 5 meter, this is 2.4, this is 3.6, this is 2.4. Then this is Z into L minus Z by L is equal to 6 into 9 by 15 is equal to 3.6. X by D is equal to Z by L, which implies X is equal to 2 meter, Y1 is equal to Y2 is equal to 2.4 meter. Then here it is 7.5 meter, 7.5 meter bending moment at 7.5 meter is equal to 625 kilonewton meter. Then it is 2.5, 2.5, this is 3.75 is equal to absolute bending moment. Note here 3.75 is equal to absolute bending moment. Note here this is weight W, this is W, this is W by 2, this is W, this is 0, this is 3 to 4 with 33%, then 1.33, then 1 by 2, 4, 3, AY, 3 by 1 is equal to 4 by X. Here 3 by 1 is equal to 4 by X. We get X is equal to 4 by 3, which is equal to 1.33, 1.33 into 3, then 0, 1, 0.3 minus 0.33 W. Then here it is A, this is B, this is W, this is 3, 1, this is at B is equal to 0, this is 1.33, WL by 2, this is AY is equal to W into 4 into 2 by 3, 24 gram, W into 4 into 2 minus AY into 3, then RA, then 1 W. Here it is negative, this can be the shear force, okay, this is W, this is 3, this is 4, this is A, this is B, W into 4 into 2 minus AY into 3, 1.33 into 3, W into 4 by 3 into 2 is equal to AY. Then here is the 1, 3 kilonewton, AY, BY, this is 1.33, this is 1, point load, AY maximum is equal to 1.33 into 3 plus self weight, okay, is equal to 24 into 9.81 into 4 into 2 divided by 3 maximum AY 0.5 into 0.5 W into 1.5 is equal to 0.75 W, 0.5 W 0.5 W A B 1 3. Here it is a W, this is W by 2, this is 1.5, this is 1.5, this is W by 2, this is 3, this is 1, this can be the overhanging beam. This is 1.33, 1, 0.5, 1.5 into W by 2 is 0.75 into W. This can be the force. These can be the forces. This is 0.5, this is 1.5, this is 0.5, the 1, 0.5. Then here can be the arch, or here can be the hinged one, 0, this is 3, this can be the hinged, 5, 3, 2. Reaction only arises when there is resistance. This is W, this is going to be the forces, 1 W, 0 W, 0.5 W, this can be forces. Then here it is AY 1. Here this one is this. Then this can be the roller spot 1. This can be the roller spot 3, 2. Then here can be the drawn like structure. This can be the drawn like structure. This can be the drawn like structure. This can be the drawn like structure. Here it can be the influence line type rolling doors. 4 points loads 8, 15 and 10 kilonewton have center to center spacing of 2 meter between consecutive loads, and they transverse a grider of 30 meter span from left to right with 10 kilonewton load leading. Calculate the maximum bending moment and shear force at the 8 meter from the left support. This can be A, C, this is 8 meter, this is 30 meter, this is B. For maximum negative force at C, this is B by L, this is Y1, this is Y2, Y3, Y4. This is A by L is equal to 8 by 30. A by L is equal to 8 by 30. This is 8, this is 22. This is Y1 is equal to 8 by theta. Y2 is equal to 6 by theta. Y3 is equal to 4 by theta. Y4 is equal to 2 by theta. Shear force at C is equal to 10 into Y1 plus 15 into Y2 plus 15 into Y3 plus 8 into Y4, which is equal to 8.2 kilonewton. The maximum positive shear force at C, y1 is equal to 22 by 10, y2 is equal to 20 by 30, y3 is equal to 18 by 30, y4 is equal to 60 by 30. This is B by L, this is y1, this is y2, this is y3, y4. Positive, this is negative 8, 15, 15, 10. Shear force at C is equal to 10, 8 into y1 plus 15 into y2 plus 15 into y3 plus 10 into y4, which is equal to 8 into 22 by theta 30 plus 15 into 20 by 30 plus 15 into 80 by 30 plus 10 into 60 by 30 is it 30.2 kN. Massive shear force in positive case. Case 3. For bending moment at the rate of C, find the lowest position at the rate of C for maximum bending moment. This is 8, this is 15, this is 15, this is 10, this is 2, 2, 2. MC is equal to A into B by L, this is 8, 22. X bar is equal to 8 into 10, 8 into 0, plus 15 into 2, plus 15 into 4, plus 10 into 6, plus 8, but divided by 8 plus 15 plus 10, which lies x bar is equal to 3.125 from 8 kN, which is negative maybe, and 2.875 from the load 10 kN, which is positive maybe. Apply the second load from the left side, 15 kN load at the rate of point C and find the maximum bending moment. This is y1, this is yc, this is y2, this is y3, this is 8, this is 22, this is 8, 15, 15, 10. yc is equal to 8 into 22 divided by 30, which approximately equals to 5.8667. MC maximum is equal to 8 into y1 plus 15 into yc plus 15 into y2 plus 10 into y3, which is equal to 8 into 6 by 8 yc plus 15 into yc plus 15 into 20 into yc divided by 22 plus 10 into 18 yc divided by 22. MC maximum is 251.2 kN per meter, 251.2 kN per meter, 8, 15, 15, 10, 3.125, 2.875. yc by 8 is equal to y1 by 6, implies y1 is equal to 6 by 8 yc, yc is equal to ab by l, this is b by l, this is a by l, this is 8, this is 15, this is 15, this is 10, then yc, then here it is y1, this is y2, this is y3. MC maximum is equal to yc into 15 plus 8 into y2 plus 15 into y1 plus 10 into y3, which is equals to 18 into 20 into 15 by divided by 30 plus 8 into 4 divided by 8 plus into 8 into 20 divided by 30 plus 15 into 6 by 8 into 8 into 20 divided by 30 plus 10 into 20 by 20 into 8 into 20 by 30, which is equals to 230.8 kN or 155.75 kN meter. The simple supported beam shown in the figure is related to 4 loads which move from left to right. Absolute maximum shear force, absolute maximum movement in the beam 80, 262, 83, 100 kN. Then A, this is B, this is 80 meter. Case first, for absolute maximum negative shear force, this is negative, this is 8, 6, 8,000, this is 2, 2, 3, this is 1, this is 11 by 18, this is 13 by 18, this is 15 by 18. Absolute maximum negative shear force is equal to 100 into 1 plus 80 into 15 by 18 plus 60 into 13 by 18 plus 80 into 1 by 18, which is approximately equal to 258.889 kilonewton. Absolute maximum positive shear force, this is 80, this is 2, this is 60, this is 2, this is 80, this is 3, this is 100, 1, this can be 60 by 18, this can be 40 by 18, this is 9 by 18, which is positive. Absolute maximum positive shear force 80 into 1 plus 60 into 16 by 18 plus 8 into 1 14 by 18 plus 100 into 11 by 18, which is approximately 256.767 kN. This can be negative absolute shear force is maximum. Case third, for absolute maximum bending moment, find the cm of loads and find the position of the loads. This is 80, this is 2, this is 60, this is 2, this is 80, this is 3, this is 100, this is 3.565, this is 3.4325. X bar is equal to 80 into 0 plus 60 into 2 plus 80 into 4 plus 100 into 7 divided by 80 plus 60 plus 80 plus 100, which is equal to 3.5625 from load 80 kN. Or x bar is equal to 80 into 7 plus 60 into 5 plus 80 into 3 plus 100 into 0 divided by 80 into 80 plus 60 plus 80 plus 100, which is equal to 3.4375 from load 100 kN. For maximum bending moment, the load we place at a distance of L by 2 plus D by 2, which is equal to L plus D whole by divided by 2. Then L by 2 plus D by 2, this is D is equal to A minus X bar is 0.4675 or X bar minus B is equal to 0.4675. is equal to 18 by 2 plus 0.4375 divided by 2 is equal to 9.2188 Newton from side A. A dash, A double dash, R, A triple dash, A 4 dash. Then it is 9.2188. This is 8.78. 18 minus 9.2188 meter is equal to 8.7812. YC is equal to 9.2188 into 8.7812 divided by 18 is equal approximately equals to 4.497. Then it is y1, y2, yc. This is 9 meter. This is 9 meter. This is 9.2188 meter. This is 5.2188. This is 9 meter. This is 8.7812. Then y1 is equal to 5.2188 divided by 9.2188 yc. And y2 is equal to 7.2188 yc over 9.2188. yc is equal to 4.497. y3 is equal to 5.7812 yc over 8.7812. Absolute maximum bending moment is equal to 80 y1 plus 60 y2 plus 80 yc plus 100 y3, which is equal to 80 into 5.2188 yc over 9.2188 plus 60 into 7.2188 yc over 9.2188 plus 80 yc plus 100 into 5.7812 yc by 8.7812, which is approximately equal to 1070.77 kN meter. Absolute maximum shear force approximately equal to 256.67 kN. Absolute negative shear force approximately equal to 258.889 kN. Absolute maximum bending moment approximately equals to 1070.77 kN meter. Draw ILD for RA, RB, MB, VG and MG for beam and beam shown below. This is A upward, B. This can be the pin spot 3 meter, 2 meter, 2 meter. G it can be pinned or hinged. This is 4 meter. This is 2 meter. This can be the pinned. This is 3 meter. This is upward. ILD for RA is like this. For this, the inclined line between A and E. Then from E to D, horizontal line. Then ILD for RB. Then this can be the one space. This can be the 4/3 inclined line upward between E and B. Between A and E, inclined line upward. Between B and F, inclined line downward. And maybe at the C point, the influence line diagram for the RB is 0. Then from F to D is the inclined line upward. The ILD for vertical reaction G. For example, here it is G is minus 1/3, it is 2/3. Inclined line downward like this. Then inclined line upward. There is a horizontal vertical line, inclined line downward. This is inclined line upward.